Hi, this is Dana Gardner, Principal Analyst at Interarbor Solutions, and you're listening to BriefingsDirect. The growing prevalence of complex multi and hybrid cloud environments has opened a Pandora's box of unseen risks around security and performance. But unlike when IT and network operators had the tools and access to track their own internal systems and data, the mixed cloud model of today is much harder to know and secure. Pandora's box is open, but observing what's going on in and around it is cloaked by inadequate means to gain insight amid all the distributed variables. Enter deep observability and its capabilities designed to provide rich access to multi-cloud and network behaviors. Such observations and data gathering can be analyzed to rapidly secure end-to-end applications and sensitive data. Stay with us now as we explore the latest advances around deep observability and how a neutral deployment approach for observation technology spans more infrastructure and services to best protect and accelerate digital business success. To learn how deep observability puts cloud chaos and hard-to-know risks back under control, please join me now in welcoming our guest. We're here with Shane Buckley, President and CEO of Gigamon. Welcome, Shane.
Hey, thanks for inviting me. It's great to be here.
We're glad to have you. So, Shane, what makes knowing and securing today's complex cloud activities especially challenging?
Yeah, it's a great opening question. We've seen over the last half a decade or more the desire for organizations to be able to be flexible in terms of where they deploy the workloads. Traditionally, workloads were deployed in a data center with a hard perimeter, lots of security, compliance, etc. within the organization. And then the desire to create more flexible workloads, to move faster, to be able to scale better, and also reduce cost. And so the cloud offers these great advantages. And we often say here at Gigamon, the cloud is simple until it isn't. And so now organizations are looking at deploying workloads in public cloud within the various CSPs. They're doing it in colos within private cloud environments, leveraging technologies like VMware. We're seeing the emergence of containers, Kubernetes, as a technique and a way to provide better automation, better scalability, and lower cost. And so the great flexibility that cloud provides is very positive to companies. It allows them to move faster in an era of digital transformation, which is specifically, of course, being driven by the COVID-19 pandemic, as more and more organizations wanted to turn their applications so they would face customers through remote access, handheld devices, phones, computers, etc. And that's given a lot of flexibility. The snag is, though, that the security footprint doesn't track as straightforwardly as the workload moves from the protected data center that the organization has to a more shared cloud-type environment. And this is the conundrum that's facing companies and organizations today. How do we make sure that we can run fast, stay secure, and innovate? And these are actually at loggerheads between each other, and that's one of the things that Gigamon addresses.
Right. So there's always trade-offs. And when we move quickly, the trade-offs can become even more risky because we have to lead on the positive, but then catch up on the negative implications. Now, when we had that perimeter and we could control it, we would know what's coming and going, but we don't have that luxury. We don't have that capability. We have to take the good with the bad. So what's been lacking now in terms of if you can't have a perimeter, how do you at least know what's going on or find the means to control your risk, moderate your risk?
That's a really great question. And so for many years, technologies like observability have been used for application performance monitoring. Observability, of course, the technique of looking at an application's performance remotely, leveraging things like metrics, events, logs, and traces, which are commonly called MELT data, has been very effective. The issue, though, is one of security. If you want to secure your applications, if you want to take a workload from a protected data center where you have layers and layers of security, because security has always been about defense and depth, and you want to shift that application into a cloud-based environment, you don't have the same controls that you enjoy when the application sits within your own infrastructure and you get control from the network layer right up to the application layer. And so the big question then for CISOs and security professionals is, how do I secure the applications that I have deployed to give the organization flexibility, but to maintain the security posture and compliance? And it's become the number one issue that CISOs face today as they try to support the business and try to support organizations' desire to run fast and innovate. But the third part is, how do you stay secure? It's really, really complex.
Now, you would think that you should be able to attain the same level of control, visibility, and ultimately security in the cloud or clouds than you had on premises. Is that not ever going to be possible? Or are we never going to catch up? Or is it simply a matter of putting the right tools and deploying the right technology to be able to bring parity to what you could do internally to now what you have to do externally.
Traditionally, organizations have used, obviously, layer defenses. I mentioned earlier on. You're leveraging things like firewalls, looking at web application technologies, data leakage prevention technologies, the ability to decrypt traffic streams. Over 90% of the threats in organizations sit inside these encrypted traffic streams, which are largely blind to the tools. And so as one moves to a cloud environment, this gets a lot more complicated because you don't own the network. The network is owned by the cloud provider. And so how in a public cloud environment specifically, or as one deploys containers, can you see inside and see what's happening? And so there is a technology available, though, that's emerging that really has a great ability to fix this issue. And that's referred to as deep observability. And we refer to it as deep observability pipeline, which I'll cover in a few seconds' time. But deep observability is about taking the technique of observability or watching what's happening to the application, but looking deep inside the flow into the network traffic. Because logs and traces are mutable. They can be turned off. And in fact, in many environments where applications are compromised, the nefarious actor will either turn logging off or, more perniciously, they'll overwrite the log. So the security operations center is fooled into thinking the application is performing as usual because logs are mutable. Network traffic is immutable. It cannot be changed. If you take a hard copy of traffic going to or from an application or a server and you diagnose that, then you know exactly what's happening within that traffic flow. And so the ability to actually get to that level of granularity, that level of fidelity in terms of what's happening inside the application and be able to extract from it key information, which you can send then to the tools, becomes really, really powerful. And so it's a technique that we've used for over 15 years. The ability to extract network traffic, send it to these very advanced tools in a very consistent way as we do within the workload sits within our data center. And now one has the ability to take an application or a workload in a data center, move it inside a container, put it inside a private cloud, public cloud, or often referred to generically as hybrid cloud, and have a consistent approach in how you actually implement your security layer.
And it's one thing to be able to capture and observe. It's another thing to be able to deal with that fire hose of data. And during the past 15 years have also benefited from the fact that we can handle big data and that we can stream in real time massive amounts of data in and around networks and cloud environments. So that's been, I suppose, an ancillary benefit. If we had all the data, but we couldn't process it, we wouldn't be able to succeed.
Yeah, so you raise a really interesting point. So as networks are now operating faster and faster, and more applications are talking to each other, particularly using technologies like microservices, where one application may make a call to multiple other applications, often referred to as east-west traffic. And that east-west traffic is not just traditionally inside the physical data center. This now could be across multiple cloud service providers. It could be across multiple different domains. Who knows? As more and more of this traffic exists, how do you actually capture all this traffic? Traditional firewalls, even cloud-based firewalls, typically capture north-south traffic. How do you capture all this east-west traffic? Because as cyber professionals will tell you, lateral movement for nefarious actors and hackers is how they get across the estate. So you need to catch them from an east-west perspective as well. Secondarily, a lot of the key information is happening on an east-west basis. So where do you actually get the context behind this? Trying to take all the traffic from all the applications all the time just creates this massive bloat. So typically a customer's SIM will fill with pretty useless information, and it takes the security operations center way too long to delve through the detail and find that one needle in multiple haystacks. And so the ability then to extract the relevant information, or in this case, metadata, from this traffic flow, which reduces the volume by over 90%, means you have a lot less haystacks to find that one needle in. It also means that you can extract the data from even public cloud networks and reduce the cost of deployment. So you're paying less fees to the CSPs as they actually take traffic in and out of the cloud environment to support sometimes custom or on-premise tools, even though the application is sitting inside a public cloud. And that gives tremendous flexibility, tremendous consistency. So it means you can keep your security posture and you can ensure that your compliance is maintained as an organization.
So while we want the deep observability, we also have to recognize that it has to be extensible observability. It has to be able to observe across this end-to-end continuum of services and data flows. So why is it difficult for us to get both deep observability and that entire panoply of observability as well?
Well, it actually isn't difficult anymore. The technology now exists, and certainly at Gigamon, we're providing what we call our deep observability pipeline to customers, in addition to the traditional observability that they get from many of those vendors. And by deep observability pipeline, I mean the ability to be able to look at the application workflows and the traffic that's going to and from those workflows at the network level, extract the data, typically it's metadata that's extracted from it, and create this pipeline of actionable intelligence that's then sent forward to the relevant tools, to SIMs and other devices, which can then absorb or extract that information. If you've got a network detection and response tool, Gigamon can provide high fidelity traffic that has been optimized and obviously metadata extraction to provide the best possible context behind that information. That's in addition to the other observability infrastructure that you have. Gigamon also has partnerships with many of the leading observability vendors where we feed directly into their dashboards and systems this high fidelity pipeline of deep observability information. So customers have the option of doing both, because at the end of the day, as we said, security is about defense in depth, and it's important for organizations to ensure consistent security posture regardless where the workload sits. Because nobody gets a hall pass if they move a workload from a protected environment like a physical data center and deploy it in a cloud environment where it's less protected. That doesn't make business sense. We got to make sure that we provide the same level of protection as that application workload moves in a flexible way from on-prem to potentially colo, potentially to public cloud.
And I suppose all the players in this ecosystem equally benefit when they have access to the data and observations. So there's no sense in trying to corner the market, if you will, or build a walled garden around your observations. This has to be sort of ecumenical, isn't that right?
100%. You hit the nail on the head. And so we often quip that Gigamon is Switzerland. We don't have a dog in the fight. Our job is to do the best possible job to take the most relevant information across all these different platforms and these different workloads and send it to whatever tool set that the customer actually is looking for. Whether you have one tool, whether you've got 1,000 tools, it doesn't matter to us. We've always been neutral in the lifespan of Gigamon as a company in providing the best contextual information to make the best possible decisions from a network, application performance, and a security perspective. And the ability to provide deep observability pipeline information extends that now to all forms of cloud in a way that's never been done before. And so we are completely egalitarian. We are completely open. We will send whatever information you want, whatever tools that you want as well.
Now, just to look into the past a bit, at Gigamon, you've said that this technology has been in the works for 15 years, but this use case, this problem set wasn't evident 15 years ago. So tell us a little bit about the background of Gigamon and why that set you in an excellent position to be able to deliver on these technologies and capabilities.
Yeah, super great question. So if we rewind the tape back a number of years, when customers would attach a tool set to a span port of a switch, that was the way they actually be able to get access to traffic. That becomes, of course, very unreliable because switches are not designed to ensure that every single packet of data on a span port is transferred. There's congestion inside the switch. When some anomaly happens in the network, oftentimes those packets and that information is lost. And so it's just not fit for function. And so Gigamon pioneered and invented the tap and aggregation technology that you take a copy of traffic, whether it's north, south, east, west, you aggregate it together and you send the traffic to the tools. Over the last 12 years or so, we've enhanced that to optimize the traffic more, extracting metadata from the network, putting application filtering rules in, decrypting traffic at the center because we see the information uniquely across the entire infrastructure. So we do an encryption once, so you don't have to do it multiple times. And we have protected and supported the largest, most secure, most complex networks in the world. And so as these networks then evolve to provide cloud or multi-cloud, or often referred to as hybrid cloud techniques, we actually use the same architectural approach that's been tried and tested over the past 15 years. So instead of physical taps inside these physical networks, you have virtual taps or OVS mirroring techniques in cloud. We then have virtual aggregation with physical aggregation. We have virtual optimization versus physical optimization. So the technique that we use inside the cloud is exactly the same textbook approach that we've provided to CISOs and organizations for many, many years. And they've relied and depended upon us to do our job very well. Now we've been able to transform this technology from an embedded solution inside a very high performance hardware device to be able to provide tremendous scalability, scale up and scale out within cloud environments. So you got a low overhead, you got a very light touch. This can be really built into the orchestration and automation systems that the cloud providers or the customers have, and then it can be scaled up and scaled out, whilst providing the same level of protection as we used to with our hardware orange box technologies that are very famous within the biggest and the fastest data centers on the planet.
Now, if we have deep observability and it's pervasive across a cloud environment or cloud's environment, we get the metadata that can be very valuable. We've talked about security, but it seems to me that observability also can provide intelligence in other areas. And particularly nowadays, the cost of cloud is going up as people use more of it, as the cost of electricity has been going up. Is there also ways to use observability in addition to that all-important security equation to help perhaps make the best use of your cloud spend, the best way that you can use and even compare and contrast your cloud activities for the best fit?
Super question. And of course, the answer is yes. The concept that one has to send everything everywhere to everywhere all the time is not scalable in today's world. Whether you're running 400 gigabit per second links in your physical data center, or whether you're running on the fastest cloud platforms in the world, it doesn't matter. There is an infinite amount of data being sent across these very large networks on a daily basis. And so the ability to optimize the data flow, so eliminate the unnecessary data, whether it's duplicates of the data, whether it's having the full payload that's no longer required because the metadata is sufficient, the ability to actually extract that information without losing the fidelity of information and reduce the quantity of information by over 90% really saves tremendously for companies and organizations. Take, for example, the speed and the capacity of their firewalls, of their other security devices across the network, their application performance tools. If you're seeing a tenth of the traffic across the infrastructure, you need a tenth of the performance of the tools. And so this is really beneficial to the customer because you end up saving money. And in a potentially recessionary environment, this is even a more important message to many of our customers. But in addition to that, because we also see all the east-west traffic, we can actually send more information to the tool while actually it needs to process less. So instead of just seeing north-south traffic, we can add that east-west dimension as well. We can also ensure that the traffic is decrypted so that all the nasty stuff or the bad stuff inside the encrypted stream is highlighted. In a very simple way, the blind spots are where the bad guys and gals hang out. We eliminate those blind spots so they know where to hang out. And we do that in a way that sends less traffic to the network.
All right, let's dig into the real world applications of this. So we've been talking at a little bit of an abstract level around the technology and the capabilities, but what are some of the top use cases for deep observability in practice? And what are some of the benefits that organizations are getting in real terms? How does this help a CISO sleep better at night, for example?
So what we typically find is customers come to us and they have used Gigamon for a decade or more. We are the visibility analytics provider for their infrastructure. We have helped protect their infrastructure for a very long time. And they'll typically have a cloud migration project. And in the cloud migration project, they'll have a requirement to move workloads. In many cases, financial institutions want to move them to maybe a colo or to a private cloud environment. So they leverage like VMware's NSXT. It could be moving an application or workload to a public cloud provider, AWS, could be Azure, could be GCP, whatever. And they're saying, how do I do this in a way that ensures that I can get compliance approval and maintain my security posture? And so we'll work with them to ensure that there are two types of migrations typically. You've got one is a lift and shift, where you take the application as it is, which is the preponderance of applications within large organizations. You pick it up, you bring it across, and you drop it down inside the environment, inside a container, private, public cloud, whatever. And then we can reattach all the tooling, the network, application performance, and the security tooling in a very similar way than before. So you don't lose anything and you maintain everything that you had from a security and also application performance perspective. The second type of application is customers say, hey, we're modernizing this application. So we're making sure this will work more efficiently in a cloud environment so it can scale up and scale out in line with the environment needs. And so that might require different tooling, but we use the very same technique. We'll ensure that we can capture all the traffic going to that app and from that application. We can process it in the way and optimize it as I just described. And then we can work with the customer to determine what tooling do they require in terms of compliance and what tooling does the CISO or the organization need to ensure the security posture of that business application. And then we can put that in place. We're seeing about as many workloads move from the public clouds to hybrid cloud as we're going the other way. And so oftentimes our customers say, I tried that application in whatever cloud environment. It doesn't give me the performance, potentially maybe the cost savings as I thought. And so I want to move it back. And so we enable the customer then to have the flexibility to take the application, put it back where it was, or indeed put it somewhere else. Maybe they're going to put it inside a private cloud environment. Maybe they're moving from a private cloud environment to 100% public. So whatever the customer wants to do, we'll work with them to understand where it was, where it's going, what the potential needs are to ensure they maintain the compliance and the security posture of that application, and also the performance of that application as well, because that's also remains a very important component too.
Well, that's interesting. So we're not just talking about observability for security and performance, but you're bringing up a portability capability, and to be able to move something into a cloud, totally modernize and make more efficient perhaps your data centers and probably consolidate them into a single or a couple globally. That's a huge economic benefit and, of course, a very difficult objective. So I didn't understand or realize the portability benefit. Do you have any sense of metrics that people have been able to share with you, some of the cost benefits that I suspect are there?
So typically when we run the analysis with customers, we'll see a return on investment in less than 6 months in terms of the costs associated with the Gigamon deployment and the savings that they'll get on a go-forward basis. And that's just direct costs. That doesn't include then, of course, operation costs and efficiencies that come with modernizing applications or moving them to a cloud framework to begin with. And so the benefits are actually quite significant. And the latest research shows that the level of deployment to public cloud is not as great as we originally forecasted. So the forecast was, around now we should be close to 60, 70% applications public cloud. We're actually seeing a resurgence of the colo as people are now leveraging things like container-based technologies and private cloud technologies in addition to the public cloud. We're seeing public cloud providers providing on-prem or colo capabilities as well, so they can actually leverage the flexibility and the ease of use of those application stacks inside the storage environments or the data center environments of on-prem or indeed in third parties. And so this ability to choose whatever's best on a per application basis is becoming very, very important. And regardless of what the enterprise does or the organization does, we'll be here to save the money.
Now, your heritage, as you described it, probably puts you right in the wheelhouse of your network operations executive or leader. But what you just described is something a bit higher, if you will, in the organization at the architecture level, making major decisions about how you're going to deploy many apps and data sets, what sort of data center, what hybrid environment, what migration path. So you need to make yourself known to a different persona, perhaps, at the architect CTO level. Is that what you're up against? And is deep observability part of helping you bring attention to a different group of planning organization types in your customer base?
I would say network operations executives and organizations have always been core to the success of our business. They saw uniquely the advantages of having a single platform or a fabric that gave flexibility of deployment, flexibility of scale, load balancing, and all the great advantages that our technology provides to customers. For over half a decade now, we've been working very, very closely with security groups as well, from CISOs through to security architects, security operations groups, et cetera, to really understand their problems. Because in many ways, the value of our fabric has been tremendously well received within security, as I said, for over half a decade. So from a persona perspective, whether you're a NetOps leader, whether you're a SecOps leader, we obviously work very closely with both. From a deep observability perspective, the majority of organizations have handed the responsibility of securing their hybrid cloud environment to their CISO. Now, oftentimes within the CISO's organization, which is becoming larger, clearly, there are new sub-personas within that space. And so we had the opportunity to work with application security people, as well as the traditional network security or security operations folks, in addition to who we work with today. The good news, though, is that they're all super well connected. They have a lot of alignment between them.
Well, because at least they should be.
Yeah, they should be. And so we're well known. Gigamon's well known as being inside these environments. It's been the core platform to ensure that we provide that security footprint. But we certainly are spending a lot more time talking to business information security officer, BISOs, as well as the application security folks to really help them understand how this technology can be leveraged within a hybrid cloud environment.
All right. Well, in addition to the personas perspective, how about the vertical use cases, even regional use cases? Is there low-lying fruit? You did mention finance. I'm thinking the regulatory issues there are probably pressing. Where is the rubber hit the road first and best for deep observability?
That's a super great question. Financial service, obviously, is a hotspot for organizations in terms of securing their infrastructure for obvious reasons. The other area that's very, very important to us is our public sector business on a global basis. And the US federal government particularly has taken a very progressive view on security with the executive order from President Biden for Zero Trust and the implementation of Zero Trust across federal organizations and contractors. And so we're very, very close to that issue as well. Securing hybrid cloud uses many of the techniques that we leverage within Zero Trust. And within Zero Trust, there are typically 7 pillars, one of which is visibility and analytics. It's considered foundational to have Zero Trust security, in that if you can't see stuff, you can't secure it. And all elements of the other pillars depend on the visibility analytics pillar to operate. And Zero Trust is not just about federal governments. It's, of course, being adopted and being used by organizations around the world. If you look at protecting critical infrastructure, that's a really big deal. So sometimes we get involved in conversations with OT, and so protecting OT devices, whether it's healthcare, whether it's nuclear facilities, other hardened and critical facilities for organizations and for bodies, that becomes a really big deal for customers as well. But within the hyperscalers and the SaaS vendors, many of the big SaaS vendors use Gigamon to provide that layer of protection up and to the application, because of course the customer can't secure it intrinsically themselves. So you'll find Gigamon's approach or connection across many different verticals on a worldwide basis. As we move in a service provider basis to 5G, a core element of 5G is the ability to extract information from these ultra-high speed networks and to provide correlation between the user plane and the control plane, provide the right traffic to the right tools at the right time. In many of those networks, you'll see Gigamon is central to the ability to deploy the infrastructure as well. So we're present in a lot of these different verticals because it's the same problem, Dana, but it's just used in a slightly different way. And when you're a fabric, which Gigamon is, you have the benefit of being able to deploy, whether it's a software footprint or a software hardware footprint or any combination across all these different environments.
Well, we've used the word ecosystem quite a bit, and that implies partners and working together with other companies. Is there a sort of a channel and or a partnership benefit here that you work through or that you help instigate in other organizations? How does this fit into a whole larger than the sum of the parts?
That's a great question. So we work, as you would imagine, with some of the best and leading system integrators and value-added resellers and other partners on a worldwide basis because they have the ability to take all the piece parts and bring them together. When Gigamon is deployed successfully, we're a fabric. We provide this pipeline of actionable intelligence and to customers and to tools. And then the tools have to take advantage of those. And so the architectural design of the network is somewhat changed because we're at the center. We're the heartbeat that makes the network and the application run. And so we work with a lot of these vendors to ensure that they can bring the whole value chain together. They have experience dealing with all the security, all the application performance, and all the networking tools so they can interconnect it all in the appropriate way and really optimize the network traffic. So partnerships within the channel community is super important. Partnerships with the ecosystem vendors, also very, very important. There are many ecosystem vendors we work with in joint marketing, joint go-to-market capabilities, joint events. So we can show that 1 + 1 = 3 or 1 + 1 + 1 = 5 or 6. And we do that on a very regular basis.
Well, in the conversations I often have, Shane, we talk about the important imperatives facing organizations, and security is one of them. Best use of cloud is, of course, another. Understanding and controlling your data, being able to understand your customers and provide a better experience across the board. And one of the salient common elements among all of these is having better intelligence about what's going on and how you can improve on it. And it seems to me that deep observability is an essential core constituent capability and pillar within supporting an intelligence drive within your organization. Would you agree with that? And do you see that how machine learning and other capabilities evolve, that the observability and metadata that you're providing is certainly an important part of making that investment pay off?
I would agree. 1,000,000% with what you just said. Having the right information at the right time is incredibly important for professionals, whether you're security or not, to make the appropriate decisions in terms of protecting the organization. How many times did people say, if only I knew, if it was only possible for me to see? I had no idea that they laid inside this application or this part of my network when I was compromised. And so the ability to eliminate blind spots so that the security team has the best possible opportunity to actually protect the infrastructure is of paramount importance. But make no mistake, This is a cat and mouse game. And in 2021, 68% of US organizations were hacked and ransomware was demanded. 50% of those had to pay ransomware. And so in the cat and mouse game, the mouse is winning, not the cat. And so our job is to make sure that we slow the mouse down and give the cat the opportunity to catch it faster and protect the infrastructure. But it will continue to be that cat and mouse game because as soon as we, and I mean the whole ecosystem, not just Gigamon, as soon as we put our systems together and our approach, the bad folks figure out ways to compromise that. That's just the way it is. But by streamlining information, by optimizing the information and ensuring that we can provide absolutely the right information, actionable intelligence to the right tools at the right time, we are minimizing the opportunity that the mouse will get away.
Well, very good. I'm afraid we'll have to leave it there. You've been listening to a sponsored BriefingsDirect discussion on how new advances in deep observability provide powerful access and knowledge about multi-cloud and mixed network behaviors. And we've learned how a neutral deployment approach to observability that spans more infrastructure and services best protects and accelerates digital business value across nearly any cloud configuration. So a big thank you to our guest. We've been here with Shane Buckley, President and CEO of Gigamon. Thank you, sir.
Thank you very much, Dana. Have a great day.
And a big thank you as well to our audience for joining this BriefingsDirect Cloud Complexity Risk Reduction discussion. I'm Dana Gardner, Principal Analyst at Arbor Solutions, your host for this Gigamon-sponsored interview. Thanks again for listening. Please pass this along to your IT operations and security communities, and do come back next time.